This is Warren from Pcte Industrial, and we're here today with Pcte FD100 floor detector. So just wanted to go through the box before we actually get into the system, and then we're just going to do a very basic calibration so that I have a chance to run through the user interface. So comes in this nice box here. Got handles on either side, nice little trolley at the back, okay, as you would need for industrial applications. So we'll just unpack that box. Okay, so in the box we have slots for some of our probes as well as the FD100 unit itself. So there is our FD100 unit. Move it back. Okay, so all of the buttons are on one side. Okay, the connections for the transducers are all on the other side. Okay, so we have an A channel and a B channel for conventional, and then we also have our connector here for the advanced Pcte and phased array probes. On the back, we have a slot to keep the protective cover, as well as some I/O at the back, so power, interfacing, all that good stuff. And then a nice little kickstand. Okay, so we're just going to turn it on. So while that's going, we'll just run through a few of the things that you get in the case. So naturally, you're going to get a calibration cert and a quick guide. So calibration cert there, and a quick start guide. One would hope if you're picking up one of these sets, you've been trained in how to use an ultrasonic set. Okay. And we also have a CD for any software that we need with this set. We also have the charging cable, an Australian plug, we have a strap, should you require it. And today we're just going to use just a simple 0 degree conventional probe. So just one of those. Just a dual crystal conventional probe. Okay, so when you start up the set, you'll be greeted with the load screen. So at this point, you can create a configuration, load a configuration, load some data, load a report, or manage your files. And on the other side here, you'll see the recent files that you have been opening. Okay, so the controls are fairly simple. You've got a 4-directional touchpad here with a confirm button or OK button in the middle and a cancel button up the top here. It's also touch sensitive, so a bit like the old iPods, well, the discontinued iPods, it's like a click wheel. Okay, so what we're going to do, we're just going to create a configuration so we can run through the UI. Okay, so after you click configuration, you'll have a choice between conventional, Pcte, phased array, or you can cancel and go back. Okay, so in this instance, we're just going to go for conventional. Once you're in the conventional menu, you have a couple of options. So you can nominate your part geometry, you can say plate, you can say you're scanning outside a pipe, and you can also say that you're scanning inside a pipe. Okay, so we'll just go for plate. Okay, you can nominate your material. Okay, so you can just type it in. You can connect a mouse to this, but you also have the ability to type in using the old the phone keypad style typing. So, for example, if I press 7 4 times, I get S, T, E, E, L. Okay, and then I can confirm that. Okay, we can nominate our thickness. So I'm just going to use a standard block today, so we'll just say 25 mil. I'm just going to say no weld at this point, but if you were to choose a weld, let's say you chose a single V, there are other options like double V, custom bevel, single U, double U, and a custom U or J prep. Okay. What you can then do is you can input the parameters of that weld. So you can say the heat affected zone, you can nominate what you think the heat affected zone is. You can nominate the root gap. You can nominate the width of the cap on one side. You can nominate the included angle for one side, and that's that. So we're not going to be using a weld, so we're just going to say none. And then from this menu here, these three buttons come into play, as you can see here. So you can say F1 is hide, F2 is previous, and F3 is next. Okay, so these three buttons are how you navigate through this menu. So we've completed there, we'll go to the next one. Okay, so then we're going to nominate our probe type. So I'm using a dual crystal, so I'm going to nominate dual crystal. You can also use a mono square and a mono circular, and questions will come up about that. For example, with the square, it'll come up with the questions about the dimensions of the square. With the monocircular, it'll just be about the total diameter, and with the dual crystal, it's the same. So we're going to nominate a frequency. So I've got a 5 megahertz probe here, so we're just going to put that there, and then we'll nominate the channel that we've connected that to. I'm going to opt for channel A. So let me just untangle these cables here. Okay, so channel A is this top one here. It's marked by the letter A that you can see, hopefully you can see there. And channel B is the one at the bottom. So we're going to connect to channel A. So we're just going to connect up this, this probe. As with any probe, you want to have a look up the top and see if there's any indicator as to which one is the transmit and which one is the receive. Normally you're looking at either a T or a red dot or something like that. Okay, and then if you did get an indication of that, you would have a look at the side here, and you would see that one side says transmit / receive. So that's for any mono crystal or single crystal. And then you see one side has received. So if you did have one that indicated to you which one was transmitting, you would connect it to this this one here that says T/R. Okay. In this instance, this probe doesn't differentiate between either side, so it doesn't matter too much. Okay. So we've nominated our frequency at 5 megahertz. We've connected to channel A, and we've nominated the diameter as 10 millimeters. So just this, your most standard of standard dual crystal probes. Okay, this one here would be if we wanted to nominate a wedge. Okay, so we could say that we have a wedge. This is, you could say you have an angular wedge, and you could nominate the parameters for that, or you could say it's flat and nominate the parameters for that one. You can then offset the X for that one, and you can say whether the contact surface is planar, concave, convex, or circumferential concave or circumferential convex. Okay, I think in this instance let's just leave it at tenon planar. Okay, in this next menu here we can nominate the index point. So the index point is where we expect our sound to come out of the probe, and we can nominate our rotation in regards to our scan axis. In this instance it's normal, so we're talking a 0 degree probe, so we're talking 90 degrees to the scan axis. Then we can nominate our range. So because we're going to be playing with a standard test block, I'll just leave it at 100. Okay, so 0 to 100 is what we're going to be working with. Then we can set our encoding. So because it's conventional, not really going to set any encoding, but if we did use encoding, we could say it was time-based. We could use the scan axis only, or we could use the scan and the index axis. So if we were encoding just for a B scan, we would only use the scan axis. If we were encoding for a C scan, we would use the scan and the index axis, or axes. Okay, then we come to this last setup. So there's a couple of things that we can nominate. We can select a layout, so we have the option of using an A scan with the B scan right next to it, an A scan with a 3D representation right below, an A scan with the B scan on the bottom. We can just look at a B scan. We can have, there's all sorts of things that we can do here. C scan based on percentage, C scan based on depth, all that good stuff. So you just choose the one that you think would be best for you. In this instance, I'm just going to stick to an A scan. Okay, then we can set our starting gain. So at this point, I'll just go and grab my standard V1. And just put some couplant on the probe. And just get an idea for what kind of gain I will be wanting. Okay, so I think we're probably somewhere there, 40, pretty high. Okay. Let's just go for the first echo at around about 100%. In Australia, you'd be going for the second echo at 100%, but we'll just go for the first echo in this instance. So then we have options here. So these options here represent these options up here. So the first one that I've got for measurement 1 is your mono pulse echo gain. Okay, I can then change it to all sorts of things relating to AWS, relating to DACs, relating to full percentage of full screen heights. I can put in my projection distance for an angle probe. I can put in my estimated depth. I can put in my actual time base, or how long the sound has actually taken to get there. So we'll just leave it at this point, but you do have lots of options to set this up just how you want to set it up. So at this point, I'm just going to accept. Okay. All right. So that's what it looks like when we're in action. So a couple of things. Down the side here, we have 6 shortcut buttons. dB relates to your gain, so we can set things like our current gain, we can set our reference gain, We can auto full screen height, so whatever selected by our gate will auto full screen height. We can set up paths, so our range and whatnot. We can also set things like 0. So this is our 0 offset. Okay, we can set our wave mode, so we've got it at longitudinal wave 5890. Okay, travel mode, half path, full time, half time. So you can put that down however you like. PRF control, so not something that we touch unless we know exactly what we're doing. If we leave it at automatic, it'll be tied to the range that we set. Okay, rectification, whether we want it full, whether we want it unipolar in the positive direction or unipolar in the negative direction, or if we don't want any rectification whatsoever. In floor detection, most of the time we're going to be looking at full rectification. Okay, we can set our filters, our sampling, our rejection. I'm sure at this point we all know that that rarely, if ever, gets turned on, and nor should we if we're testing to a standard. Smoothing, contouring, averaging, all of these things are software functions, IFT, and then we can change our probe connections as well if we wanted. Okay. This next button next to the DB is it relates to the gates, so we can move them left, right. If we press the OK button, we can widen the gate, shorten the gate. If we press up, we can move the gate up, move the gate down. Okay, so, and if we use the click wheel, we can move it up and down. Okay. This next one will show you your skip, so you can turn those on and off. So if you've got everything set up properly, you'll be able to know when you're at the bottom of the plate, top of the plate, or going back to the bottom of the plate. Okay. Okay, let's start with the first reflector. So our first reflector we said was 25. So we're going to move this over and just go next. Cancel that. Move that over. Okay, so that's what we want, so that's 25. We'll go next, and then this is our second reflector, which we said was 10. So I'll just get some more couplings on here. Okay, let's just maximize that. Okay. So let's go get the second cursor. For the gate. Move it over. Move it down. Okay, there we go. And then let's go next. That should be, that is at 10, and this is at 25. Okay, 24.9, good enough for now. You would fine tune that if you wanted more accuracy out of it. Okay. And then we'll just say, let's just say next. Wizard's been completed, and we're done. Okay, and there we go. right at 25. So that was just a brief introduction to the FD100. We will come out with some more videos in regards to calibrating for angles and connecting things like phased array and Toft. If you would like a demo of the ProSec FD100, please call your local Pcte manager and we will organise to bring one of these out to you. Thank you very much for your time.